Okay, so we left off on Friday. We had been talking about percents, and we looked at some applications of that rate method of percents, mainly looked at commissions. So I want to do a little bit of review of percent decrease and increase today. For example, let's say you order supplies and you pay, let me get a good number going here for it. $735. After a 2% cash discount. So the question here is, what was the full price? So when we look at this, the 2% is our percent that we have in the problem, 2 over 100. And of course, the 2 represents the discount. Of course, this gets the cash discount. That just simply means you pay the day of service. And the 100 is the full price. Remember, 100 is always typically the full amount of the starting amount. And here it's the same thing. It's the full price, or it's the starting amount before we took the discount. So when we go to set up the other side of our proportion here, 735 is the price after the discount. It definitely does not match up with the 2%. And it's not the 100% either, because the 100% was the price before the discount. So the 2%, this proportion doesn't set up. The 735 doesn't go in either spot here. What did we do with this to make this work? How did we adjust our percent to make these types of problems work? Well, remember, we had 100%. We had a 2% discount, which meant what was paid was 98%. Good. So we had 98%. So we look at 98 out of 100. And now we look at what those represent. The 100 is still the full price, or the price before the discount. The 98 is the price after the discount. And that, of course, is where that $735 falls in. So now we cross multiply and divide. 100 times 735 divided by 98. Giving us $750. That was the full price. Now we have to go back and make sure we've answered our question here. And in this case, the question was asking what was the full price. So that is the answer, $750. The only reason we have to double check is sometimes we're asked how much was the discount. If that were the case, we'd have other things we would need to do. So on the other side of it, let's say that after adding 12% for waste, Sam figures they will need $504 studs to frame a house. So the question here is, how many are added for waste? So again, if we look at that 12%, 12 out of 100. The 12 is the amount for waste. And the 100 is the amount before waste. And of course, we want to know how many are added for waste. So that's the number we're looking for. But again, the 504 does not represent the amount before waste. That's the amount after waste. So in this case, what do we do to adjust our percent? We add 12%. So it's 100% plus 12% means we're working with 112%. So that's what we're looking at, 112%. 112 over 100. And of course, the 504 was after waste. That goes with the 112. And we'll cross multiply and divide. So 100 times 504 divided by 112, and we get 450 studs. And yes, I heard somebody say that's a lot of studs. That is a rather large house. Not as big as you would think. The average house, like a 36 by 48 on the outside would take about 160 to 180 studs, depending on how many corners there are and how many doors and windows. So if you're looking at interior walls, you can easily double that on interior walls. So it's not as big as you might think. But anyway, one of the ways we could have approached this if we had used the rate method is just to use the idea that instead of 112%, we could use the rate of 1.12. So then we know that the beginning amount times 1.12 equals that after amount, after we've added the waste. So to work backwards, it would have simply been that after amount, the 504, divided by 1.12 to get the 450. Now, this process here of taking 100%, adding 12 to it, and then converting it into that rate of 1.12 is kind of the heart of what we're going to look at for today when we talk about interest. Interest, of course, is something that's paid on either a loan that you pull out on money or an investment you've put in. It's something that at some point in our lives, every one of us is going to either draw interest or have to pay interest. Very few people make it through life without having some sort of a loan. So we're going to start off with simple interest for 1 year. And the formula for simple interest for 1 year is just a rate-based formula. The amount of interest is equal to the principal. So the principal is just the starting amount of money times the rate. So let's say that you invest $6,000 at 5% for 1 year. Your interest what number up there is the principal? The starting amount of money is the $6,000, right? And then what's our rate? 5% will become what is the rate? So 0.05, good. So then we multiply that out, that is $300. So $300 is our interest. if we want to find something called the maturity value or ending value, it's simply the principal plus the interest. So here we would have the $6,000 principal plus how much interest? $300. Good. So $6,300. So our total amount is $6,300 at the end of that year. Well, if we look at what happened here, we started out with the $6,000. Well, that was the beginning amount or the whole amount. That was 100%. And we added $300 to that. Well, that was our 5% interest. So the ending amount was 105% of what we started with. So we could have used that rate method. We could have taken our principal of $6,000, and instead of finding 5%, we could have found 105%. What rate would go with 105%? 1.05. Good. When you multiply that out, it is $6,300. Now, one of the weaknesses of simple interest is this formula, or this formula for simple interest, is it requires our time to be exactly 1 year. In the most cases, most applications, time is not exactly 1 year. So let's say you want to invest, and let's have you invest, let's do $2,000 at 8% for 3 years. So, and this is going to be simple interest. One of the traits of simple interest is not calculated until the end of the loan. Or the only other way it's calculated is if there's an action on the loan, whether money is paid in or drawn out. Actually, car loans are technically simple interest. Most car loans only calculate interest when you make a payment. So when you make the payment, the interest is calculated, and then they put your payment towards what's the balance in the account. But anyway, simple interest for 3 years means the interest would not get added in until the end of the 3 years. So we would modify our formula here to get the total interest would be the principal times the rate, but then times the time, where the time, of course, is in years. So for this problem, what's our principal? $2,000. Good. What's our rate going to be? So 0.08. And then the time? 3 years. So if we multiply that out now, 2,000 times 0.08 times 3 is what, $480, I believe, in the interest. And then so the maturity value is the 2,000 plus the 480, or the 2,480. Now, the problem with that, weakness with that, is most banks do not want to do simple interest if it's 3 years. Banks want to know what their interest liability is on a regular basis, usually monthly, but at the very least every 6 months. So anything longer than 6 months, they typically don't do simple interest unless it's something, like I said, your car loan, where you're required to make a payment every month, so they'll have to pay the interest or figure in the interest at that time. So most simple interest investments, at least, are shorter term. So if you invest, let's do $5,000 at 6% simple interest, for 3 months. So the interest here, I'm just going to put I for interest. What's our principal here? What's 6% will be the rate. Yep. What's the principal going to be? 5,000. Good. Then, of course, the 6% as a rate will be 0.06. Now, here's the tricky part here. The time is 3 months. Up above here, we said the time was always in years. So to turn 3 months into years, 3/12. Very good. So now in the calculator, we don't actually need to use the fraction function for the 3/12. We can just do 5,000 times 0.06, and then just times 3 divided by 12. Doesn't have to be entered as a fraction. Gives us $75 in interest. And of course, we can add those together, giving us a maturity value. 5,000 plus 75 is $5,075. Yes. Okay, so back to this example here, where we're at there for 3 years. We said we wouldn't use simple interest there because it's too long. The bank doesn't want to wait 3 years to figure out what they owe. So typically what they'll use in something like that is compound interest. And compound interest just means that rather than waiting until the end of the loan, even if there isn't any payment or withdrawal, they're still going to figure out the interest and add it to the balance every so often, whether anything happens or not. And so the biggest thing with compound interest is the period. So period could be monthly. Monthly means how many times a year? 12, good. Or quarterly, which would be how many times a year? How many quarters in a year? 4, good. Semi-annually, less common because it's almost too far apart. Semi-annually would be how many times a year? Twice. Yep. Now there are, if this were a business and banking class, which it's definitely not, we would do daily compounding and stuff like that too. We're not concerned about getting into that detail with it. But we'll look at maybe monthly or quarterly compounding and see how that affects things. So let's redo that problem up above. Let's invest that same $2,000, still at 8% interest, but instead of simple interest, it's compounded quarterly for 3 years. So let's look at what is happening here. So we're going to start out with a beginning balance every year. We're going to figure out our interest. And then we're going to get an ending balance for every year. So for, not even just year, for every quarter, so I should say. So for quarter 1, our beginning balance is the $2,000. The interest, well, 2,000 times, what's our rate? 0.08. And it's quarterly, so it's 1/4 or 1/4 of a year. So what does that come out to be? $40 in interest, I believe? So the ending balance is 2,000 plus 40, or $2,040. We would start out quarter 2 with the $2,040. So that interest, the principal is now $2,040. The rate is still 0.08. What's that? Okay. Times the 1/4 of a year, 1/4 of a year. So 2,040 times 0.08 times 1/4 gives us $40.80. So notice we already got more interest because of the compound interest. We add that on, we're now at $2,080.80. Well, that's only the second quarter. How many quarters would we have to go through to get to 3 years? How many quarters in 3 years? 12. I don't feel like doing all this 12 times. So in order to avoid doing this 12 times, let's look for a shortcut. So the shortcut here involves us adjusting two things. First, let's look at this right here. 0.08 times 1/4. Well, the 0.08 is the 8% annual interest. The interest is always an annual rate or for the whole year. The 1/4 is because we're going to compound it every fourth of a year, so we only do a fourth of the interest each quarter. So 0.08 times 1/4 is 0.02 or 2% a quarter. Which makes sense. If it's 8% for the whole year, 1 quarter would be 2%. Well, then if we go back to what we were looking at the beginning of class here with that percent increase, we started with 100% at the beginning of the quarter. We added 2% to it. What we ended with is 102%. So to get from the beginning of the quarter to the end of the quarter, we could just multiply by 102%, or what would that be as a rate? 1.02. So if we did 2,000 times 1.02, that would be 2,040. That's what we had for the ending balance at the first quarter. We did the 2,040 times 1.02. We get $2,080.80, the ending balance at the end of the second quarter. So each quarter, we would multiply by 1.02. How many quarters do we have to do that? How many times do we have to multiply by 1.02? How many quarters in 3 years? 12. Good. So in math, if we're going to multiply by the same number over and over again, we have a function for doing that. Instead of just multiplying by 1.02 over and over again, we'll multiply by 1.02 to the power of 12. So $2,000, our principal, times 1.02 to the power of 12. We get 2536.48. Now you compare that to what we had for simple interest, which was the $2,480. So over here we had almost $60 more from the compound interest. Well, that doesn't seem like a big deal until we look at the bigger picture. So you guys are in high school, so I'm guessing the oldest one in the group's probably around 18. Well, let's take a peek at getting out of high school. You're the oldest one? Okay, so anyway, let's say that from here you go on and you next year you get that first full-time job paying well. Right now you're in high school, probably living with your parents, living cheaply, driving whatever vehicle that they have for you to drive. You're living fairly cheaply is the point. Well, next year you're working full-time. A lot of people want to move into their own place, get a new truck or whatever. But let's say that for a year you decided, I'm going to keep living the way I am right now. I'm going to live cheaply. I'm not going to buy that new truck. I'm going to drive my old vehicle, stay living with my parents or whatever for a year or two. How much money do you think you could save up in a year and put away? Probably quite a bit. Anybody think 5,000 would be too hard to do? Yeah? I would say we could probably save up $5,000. Right. Well, think think about, moving on to a construction job or something where you're going to be getting 18, 19, 20 bucks an hour. You could, even if it was, $2,000 a year, it would still be a significant payment. And I'll show you how to figure that out as well. So you'll be 18 years old. Right now, the Social Security Administration has said, even for me, I have to be 68 before I can draw full Social Security. So at 68 years, I can retire, basically. How many years are there between there? 50 years. So now let's go. Let's use Nathan's number of 2,000 here. So let's say you can only put away $2,000. Not a big deal. But if you're investing it for 50 years, if you look at and I'm not talking about going to the bank and putting it in a 3-year CD or whatever. I'm talking about going to an investment planner like an Edward Jones or Fidelity, one of those that does professional investing. The average annual gain for any 50-year investment is between 12 and 13% a year. So should we shoot on the low end and go 12%? So what does that mean? Well, that means if you start the year at 100% and you add 12% interest to that, what percent do you have at the end of the year? 112%. So if we take our $2,000 that you invested at 18 years of age times, what's 112 as a rate? 1.12. For 50 years, that's to the power of 50. So 2,000 times 1.12 to the power of 50. Anybody want to guess on how much money this is going to be? $578,000. $500,000. Yeah, so this is putting it away at 18 and never touching it till you hit 68. At 68, you would have $500,000. Now think about that. That's just once at 18 putting away $2,000. If you did that for a few years, you'd very easily be a millionaire in your retirement. So this is if you do it at 18. Let's say that next year you decide, hey, I don't want to stay living with my parents. I want to get my own place. And I don't like my own car. I want a new car or a new truck. I want to have some fun. I'm young and I'm making money. And so you decide, I'm not going to put any money away, and you wait till you're 28 years old. So now, if you put that same $2,000 away when you're 28 years old, assuming you can still get 12%, now it's only going to be how many years? 40 years. So 2,000 times the 1.12 to the power of 40. Anybody want to guess? 186,101. You get about a third, actually a little bit less than a third of what you would have if you'd have put it away 10 years earlier. Well, let's say that even at 28, you say, I'm still young. I don't want to worry about retirement. You wait till you're 38, and at 38, you decide, okay, now it's time to think about it. And you put away that same $2,000 at 38 years of age. Now how many years is the money going to be sitting there? 30. So you're thinking about 80,000? So the power of 30, we're getting about 59,919. Again, slightly less than a third of what you would have had 10 years earlier. So by waiting, instead of waiting from 18 to 38, you get about a tenth of the return on what you invest. So I'm going to get up on my soapbox for a little bit here. Just because I feel like this is one of those things I have to show you or I haven't done my job. We're going to play with a spreadsheet a little bit here. Once it loads. Now, you are allowed to start putting money away in retirement accounts starting at 16. By chance, are there any of you that actually have started putting any retirement accounts away? No? Don't worry, it's not. I wouldn't expect it. Most of us don't think about retirement till way after the age of 18. So, let's start at your 18 years of age, though. Oops. And let's go up to 68 again. So we'll stop right there, 68. And let's just stick with the $2,000 a year for now. I'm going to format these to be money. So we're going to invest that $2,000 a year, not just once at 18, but we're going to invest it every year until you retire at 68. So we have that amount. And let's fill this down. Anybody want to guess what you'll have at 68 if you do $2,000 every year?
$10 million.
About $5 million. Pretty impressive number, isn't it?
That's a lot of money.
It is a lot of money.
Go down a little bit.
Give me just a second here. Let me paste this. What do you want to look at?
That big jump right there.
Here?
That big jump.
Well, it's only... Is it? Yeah, it does look like a big jump because you're right. It goes from the 90,000s up into the 100,000s, but it's only 14,000 that it's adding. You know, from here to here, it's adding 15,000. From here to here, it's adding 18,000. That's just the interest building up. As that number gets larger, that interest gets to be more every year. Now let's do this. You're 18 and you decide I want to have some fun with my money. I'm going to play for a few years. So 18 through 25, you play with your money. You don't put anything away with retirement. Anybody want to guess what your total is going to be for retirement now?
Like $1 million.
About 2.1 million. You've lost over half of your retirement by not doing that first few years. Here's the part that's really kind of impressive to me. Let's go the other way. So this person here decided to play until they were 25 and then started putting money away. This person over here is going to put money away from 18 to 25. You're young, you don't have kids, why not? You don't have all the big expenses of a house or children and all that stuff, or a wife, all those things to play for. So you put away that $2,000 every year. Then at 26, you decide, okay, now I want to start having fun with my money. Maybe it's time to start having kids. No offense, but once you start having kids, it's a lot harder to put money away. Kids can be expensive. So at 26, you decide, I'm not going to save anymore. You save from 18 to 25. You say, okay, I'm done. No more saving for me. Anybody want to guess how much you have?
Like $1 million.
3.2 million. These first 8 years here, from 18 to 25, are worth more than that other 32 years from 26 to 68. 3.2 million just by saving from 18 to 25, or you can save for 40 years and only have 2.1 million. I don't want to sound preachy, but I'm going to here for a minute of, you guys are young. Now is the time to start thinking about retirement. Putting away, even if it's just a few $100s every year, starting at 18 or 19, makes the world of difference when you retire. As you can see here, this person that started at 25 never caught up to the person who only saved for a few years from 18 to 25. In fact, let's see where they break even. So let's say this person started saving a year earlier, and this one stopped saving a year earlier. Now they're still ahead. Do you think, one more, do you think that'll do it? So this person started saving at 24. This person only saved for 6 years from 18 to 23. Almost dead even now. So that first 6 years of your life, starting at 18, is worth about as much as the next 45 years of your life after that. A little depressing, isn't it? Or for you guys, being your age, it's a good opportunity, I suppose. Anybody have any numbers that they want me to plug in here just to see how it turns out?
Like 500, a small number.
500 a year?
Yeah.
Okay, so if you start with 500 a year, now 500 a year is only, what is that, like $60 a month? Not even $40 a month? That's not bad, $20 a paycheck. You're still going to be a millionaire if you do 500 every year till you're 68.
Try 5,000 a year.
5,000 a year?
Price tag of this bad boy.
I'd be willing to bet you go over the $10 million mark. Oops, I gotta go one more here. You go well over the $10 million mark. 13 million. So let's say you're a little more conservative and you only go for, instead of getting 12%, you get 10% on your money. It doesn't sound like it should make a very big difference, does it? But when you drop it from 12% to 10%, you go from 13 million down to 6 million. That 2% cuts your return in half over that 45 years, 50 years. Somebody was saying, try a different number. Go ahead. What do you want?
Go to 6,000 with the interest of like, I don't know, 50, 12.
Go back to 12? 11? Okay. So I'll do the interest first here. Then 6,000 a year. Anybody want to guess? About 11 million. $6,000 a year is about $500 a month, which is about a car payment, a big car payment, but it's doable if you're willing to live cheaply. It's doable. 10,000?
Yeah, 10 grand a month. 10 grand a year.
So that's about $800 a month. What's your interest rate you want? What interest rate do you want? 11? Okay, so stay with the 11%. I would say somewhere around 16, 18 million. There you go. So I realize, like I said, I know I'm getting a little preachy on this, but something to seriously think about when you're young. Any other numbers you want to see run? So let's say you wait until you're in your 30s. At 31, you decide, okay, I'm in my 30s, now I'll worry about retirement. It's a huge hit. You can still make it to $1 million, but you're not going to hit the big money you would starting at 18. Okay, I'll shut that off here. It's something to ask about. Talk to your parents about it or whatever. Like I said, you are actually allowed to start putting money away in retirement accounts starting at the age of 16. So you can actually put money away this year if you wanted to. I also realize when you're in high school full-time, it's hard to make enough money to barely pay your own expenses. I get it if you don't have extra cash laying around. So anyway, I realize some of you were gone on Friday, but I gave you guys a quiz on Friday on percents. So we're going to take a little bit of time right now to work on that quiz. Yeah, I know, Damon, you weren't there, so you don't have one. If you just want to look over somebody's shoulder and write down the problems quick and do them. I'm going to pause the recording here, and then we'll give you some time to work on the quiz. I realize some of you will get through this quiz pretty quickly, so if you get done with the quiz, I'll give you the homework here so you can get started on that. It's in the little book. Unit 17 and 18. Again, just do the odd numbered problems. So are you done with the quiz? If you just want to jump into that, we'll talk about some things in a little bit. Looks like most of you are done with the quiz, so that's good. We'll collect that from you on Friday. Just so you guys are aware, this brings us to the end of Unit 1. So Friday's class we'll review for a while, and then we'll give you the Unit 1 test. And I'll have some extra credit opportunities with us to work on then as well on Friday. Because I've been told that this is the end of our mid-quarter, so I have to submit a mid-quarter grade for us. So if you have any late quizzes or missing quizzes or stuff, please bring those with you on Friday as well. And we will work on getting those made up so that we can get good mid-quarter grades in for everybody. So with that, I'll let you guys have the last 10 minutes to work on that homework out of the little book, Unit 17 and 18. Then we'll excuse you here in about 10 minutes.